Right, more algebra. Okay, but again, think about it with real numbers. You've got a $15 coupon. It can be used on any purchase over $100 at your store. Okay, so think about it. The price of the jacket, it says it's $116, but you're going to get $15 off that. Okay, so again, what we're saying here is the final price, which is the discount price, is going to be, okay, this $116, and you're taking off the $15 discount, so the final answer, okay, is going to be $101, okay, because you took $15 off. Okay, so again, the input and output. Well, the input, the important thing, okay, is the sports jacket. All right, the price of it. Then when I take off 15, the 15's got nothing to do with it as in X's and Y's. That's just what I'm going to take off. Okay, the output is the final discount price. Okay, the Y value. Now I'm going to jump ahead here. So think about it. Normally, didn't we just say I thought input was X? So isn't it going to be this maybe? Whatever I have that's over $100, no matter what, if I take off $15, I will get the answer, the discount price, which is the Y. So that's kind of equation I'm looking ahead right now that I might be doing. Okay, what's the discount price? Okay, what's the answer? The Y. Okay, here's the price of the item. Can be anything. Let's call it X. But when I take off $15, I'll get the answer. Okay, I'm taking off $15 off anything over $100. Okay, so let's look at the next sheet. And I've kind of just done this. Let X represent the input and Y the output. Okay, so I think that's what I just did. Okay, so whatever I eventually pay the discount, I am just whatever the original price is, I'm taking off $15. Okay, so for all of these, all right. So can you see this? If I take off $15, that's going to be 90. If I take off $15, okay, this is going to be 120. What I'm doing is, again, here's the X, which I would put there. I would then take off the 15, and I get the Y. Okay? And then you do it in your head all the time, but think about it. I've just created an algebraic equation. Right, so now how about this? Again, looking at the previous section where we were looking at sales tax. Supposing you know the discount price. What was the original sales price? So again, I'll write that equation somewhere. Okay, so remember, Y equals the original price, and I take off 15. So again, that Y is the discount price. Okay, now then, I want to know what the original retail price is if the discount price is 187. So what we're saying is this is where the 187 is going for this instance. Okay, so what was the original price? Okay, before I took off the $15. So now here's the thing about this. Okay, so how do you get to that X? All right, I want to know what the original price is. So by the way, just check on this. Remember, 187, if it's the discount price, is the output. Okay, there it is. Now then, what you're going to do is you're going to add this negative 15. Okay, think about it. I've got a minus 15. How do I get rid of it to leave that X by itself, sorry? I would add a 15. Now I'll write it down below. Let's have a look at this. Let's look at what they've done in the book. Okay, so here it is. Here it is again. That's what I wrote. Solve for X. Can you see? Here we go. They have just added 15 to both sides because what's negative 15 plus 15? Gone. Just like I was cancelling these over here. Remember? Think about that. I'm pointing. Okay, the number next to the letter. Here's the one nicely clearly written. To get rid of that 3 next to the X, I divided by it. Okay. This time, to get rid of that negative 15, I added a 15. All right, to get rid of it. And if I do it to both sides, I will get $202. Well, let's think about it. Was the original $202? So when I took off the $15 discount, yes, I would get that 187 discount price. Okay, that's just me checking. All right. So again, that is the algebraic expression. Okay, for this one. Now, I think that's pretty much it for that, because after that, this is just showing you, logically how we use it in real life. Okay. What you're going to see sometimes on tests is just straightforward things like this. Look at this. Right, I'll make the pen a little bit bigger. Okay, what we're saying is solve that. I want to know what X is. All right, it's got a plus 9 next to it. How to get rid of a plus 9? I would minus a 9. Think about it. That's gone. So all I'm left on the right hand side is the x. But don't forget you should minus the 9 from the left hand side as well. You've got to do it to both sides to balance it. Okay, you can't just do it to one side. Okay, I'm balanced, all right? Nicely balanced. This equals this. I've got 3 eggs here, I've got 3 eggs here. If I add an egg to this side, it's going to go, well, I'd better add an egg to this side to make it 4 equal. Okay, I've got to do the same to both sides to balance it again. So that's going to be 10. You just found it. X must be 10. Check if you want to. Yes, is 10 plus 9 19? Yes, it is. Okay, again, I want to find this. Minus 1 right now, so add a 1. Great, gone, but don't forget, add a 1 over here. Well, again, for that one, x must be, doesn't matter which side you write it on, 23, okay? 22 plus 1. There you go, okay? Now then, so have a look at these. I think I showed you these. Remember these that ones with the sales tax? You just divide by the number next to the letter for these down here. So for this one, I'm going to go, right, divide by 6. Some might prefer doing these. Divide by 6. That's saying it's kind of gone, it's cancelled. I mean, 6 divided by 6 is 1, but I'm just looking for 1x, what that 1x is. And that is, now for this one, x equals negative 2. Okay, there's a negative there. So 12 divided by 6 is 2, but it's negative 2. Again with this one, divide by the number next to the letter. Divide by 7. And over here, divide by 7. X must be equal to negative 3. Okay? And, you know, there's things down here with decimals. I'm not going to go on too much with this because some of it gets a bit more advanced. I won't do these just yet. I'll come back to things like this. I mean, here, I would, if I want to get the x by itself, then surely, let's erase that, I'm going to take away, remember, I want this by itself. I'm going to take away 9.3 because it's a plus 9.3. If I subtract it, it's gone. If I do the same to this side, if you need your calculators for that, go ahead. Okay, but x is going to be equal to, and negative 4, another negative 9.3, I know is negative. Okay, it's just more negatives down the number line. 13.7. Okay, 13.7. And that's just me doing it with decimals as well. Okay, so there you go. That is your classic algebra. How do you find x? Okay, you're going to add or subtract something or divide by the number next to the letter. Okay.